Okay, so with that, we'll move on to our keynote speech. We've invited here today Dr. Andrew Dent, who's Executive Vice President of Material Connection. So he's a material innovator from the US and a leading expert on sustainable materials. His work has helped create a new generation of more sustainable products, working for many companies such as Whirlpool and Adidas to BMW and Procter & Gamble. It's a pleasure to welcome him today for his presentation. And with that, I'm going to pass the word over to him. Thank you, Andrew.
Thank you so much. And thank you for having me on this, this event. Just wanted to sort of like introduce myself. So I was originally a scientist, but I'm now heading up a company called Material Connection. So my job has been for the last 20 years to help a range of different clients, all sorts, including people who make virtually everything. A lot of it does include packaging, but also includes cars and interior spaces and consumer electronics and home appliances, fashion items, footwear, basically everything that's made out of a material. We've been helping those clients for the last 20 years find more innovative and more sustainable solutions. So we deal with a lot of brands, and we also deal with an awful lot of vendors and manufacturers as well. So I think my perspective here is perhaps less detailed and granular and more to do with the wider world of materials and packaging. Okay, so these are the sorts of industries that we deal with and have worked with all the household names that are out there, just trying to basically solve material problems. And we are talking often to all sorts of different vendors, whether they are well-established producers of materials, whether they are startups or universities or research institutions. Whoever's got the right materials for the job, that's the people we're talking to in order to solve these problems. I run a consultancy as well as large material libraries. So we have physical material samples out on display. I've got one here in New York, just near Grand Central, right in Midtown. I've also got locations around the world as well. So we have these types of material libraries that are all over the world, helping people get access to innovative materials. Because of course you can talk about materials a lot, but the most important thing is when you can actually put them in your hand, because a lot of the value of packaging, of material selection is related to how people feel when they get the product in their hand. So material, texture, the way it looks and feels, that sort of thing is very important as well. So physical samples to us have always been key. That's my background. I'm talking to you now probably for about 25 minutes about packaging in general. I wanted to kind of include a wide range of different types of materials and also of different industries, just to kind of give you a broader view and kind of where we are and what we see when it comes to sustainable materials in packaging, some bio-based, some recycled, but kind of hopefully going to give you a sort of broader overview about where we are in the world. Okay, is there a way I can move the screen? Okay. Okay, sorry, I've moved you guys to the left-hand side so I can see my own slides. Anyway, okay, so the various different sections. I'm going to talk a little bit about recycling, some plastics in the ocean, talk about some success stories, who's done well in terms of packaging, where are we seeing some great sustainable packaging out there in the world. Bunch of materials. I want to show you some of the new stuff I've been seeing and what we're excited about, and then I have a few ideas about the future of sustainable packaging. Okay, so where are we with recycling in the world? I thought I want to include this one just because I feel like it's an interesting sort of overview of in terms of potential materials that could be used. I wanted to go through a few of them just to kind of explain, I think, where we are in general. Okay. Everyone probably knows how China's National Sword Directive basically has screwed everything when it comes to recycling and the use of recycled materials. So I thought it was just interesting, here in the US, we've come up with a bit of a conundrum because whereas previously we are basically getting money to send stuff over to China, we're now having to pay to get rid of it. So that's actually changed the way in which we approach recycled materials. And some, of course, class it as a calamity. The concern that basically we've now got more and more landfills full of materials that could have been used for recycled content over in China. But now, my hope now is, my belief is that pre-COVID, the idea was that we're getting an awful lot more of suppliers who are thinking, okay, well, I've got a bunch of these resources, what am I going to do with them now? So how am I then going to use my existing waste materials I typically would have sent elsewhere, can I now do something with them? And we've seen a whole bunch of different companies pop up that are using materials that traditionally would have gone to China, and now seeing what they can do with them. So there's just a sort of imagining of recycled materials to see what we can do with them. Just some, in terms of what we can do with recycled materials, or what the resources that are available at the moment, in terms of the harder, more traditional materials, we've got a bunch of aluminum, very little glass. So if you're trying to use recycled material in glass, we traditionally believe that glass is a good material to recycle. We all of us do it. Basically, we put it in the recycling bin. Challenge is, at the moment, in food packaging, virtually none of it is used. Unless you simply just take the bottle back and wash it, when you crush it up, recycled glass is not typically used in new content. We've seen a few cosmetic jars being made out of 100% post-consumer recycled content, but very little else. So although glass is great to recycle, it's not typically used back into food or cosmetics packaging. Paper's excellent, fair enough. We use an awful lot of that. Of the plastics, it depends what it is. Polyethylene, an awful lot of resources for recycled polyethylene. Mostly in high density polyethylene. There's very little low density. Most of that is really just not approved for food contact use. There's not really much use there. Polypropylene, there's some recycling it. We're getting better. We have, the challenge of course is always making sure that you've got a viable resource for it. The reason why polyester is so excellent is because we know that there is a high volume of clean polyester suitable for food packaging out there because we're basically all, well, certainly Americans, a lot of the rest of the world are drinking soda drinks. So we know that I can guarantee I've got polyester that's really only just gone from the supplier to the shelf to my house for a few days. I drink it, I then put it in the recycling. There, it's a relatively clean resource. So there we can almost guarantee that that material is can very easily be then made into more food contact use. It's not so the case with many other plastics. That's the reason why PET is so much used, is because you've got that viable resource. I also want to sort of quick one in plastics in the ocean. We've got a lot of our clients who are interested, okay, I want to use plastics from the ocean. There's an awful lot of stuff out there in the ocean. It looks very bad. We're worried about more and more of it going in there. What can I do to perhaps mitigate that, reduce that? Can I use some of the plastics that are out there? And also the other question is, what degrades in the ocean? If I'm going to be making some packaging, I want to make sure that I'm not one of the culprits. Don't want to see my beverage bottle or my food container out there on a beach or in the ocean. I want to make sure that it's degrading properly. Problem is, if in terms of degradation, I mean, these are basically, this is just my sort of attempts at looking at what the research is out there. These are the three materials that break down easily. Of the plastics out there, of course, it depends upon, biofilms, etc. But rayon, cellophane, and PHAs and PHBs are really the main ones out there that are for food packaging, apart from the water-soluble ones, of course. These are the three main plastics that are degrading easily. It's not much. So there is that concern. So obviously, PHA, PHB is a good potential viable material, and we're seeing a lot of development in that. I'm sure there's been a lot of research by some of you people out there in that material. But this has been the challenge in terms of materials out there in the ocean. Very few of them actually degrade very well. Of the stuff that's already out there, this is interesting because we've got clients who want to use ocean plastics in their resource, but the vast majority is nylon. The reason why it's nylon is for one simple reason. It's fishing nets. If you think about collecting plastics from the ocean, think about physically what I'm going to do. For a fishing net, as long as I grab one end of it and pull, I've potentially got 50 pounds of plastic right there in my hand. Okay. The alternative, I'm just doing it for plastic bottles. I go into the ocean and grab one handful. I've got one bottle. It's not an awful lot. So the collection methods for these different materials means that you've got a much greater and more viable resource of nylon, not typically used not so much in food packaging, but that's why it's easy to get resources for nylon, not so much for the other ones. So you do have other materials out there in the ocean, but the challenge is, of course, collecting them. It's, you spend an awful lot of energy collecting maybe a ton of plastic bottles. It's much easier when it's fishing nets. These are some of the resources they collect from the ocean, but there are a number of different companies out there doing that, taking those resources from the ocean. The majority of them, as I said, are using nylon as a base source. Then, of course, there is what we call ocean-bound plastics. Now, this is where because it's hard to collect stuff exactly from the sea, people have now sort of extended that now to things that are about to go into the sea, what they call ocean-bound plastics. And this is a quick image of some of the areas where you're getting an awful lot of ocean-bound plastic. What that means is plastics that are either on the beach, either in coastal communities, or about to go into rivers that will eventually end up in the sea. So rather than stuff that's already in the sea, this is the stuff we can collect before it gets to the sea. And there you've got a much higher density, and it's much easier because you simply can have a whole bunch of people walk along the beach or walk into a community and then pick up all that plastic before it gets into the sea. The advantage, added advantage, of course, is that it hasn't, once it gets into the sea, it tends to break down a little bit. A lot of sun, salt water, etc. It tends to degrade the plastic. And although there are now some suppliers, there's one in Switzerland, I think, that can actually add in a chemistry to revitalize that plastic, there is a certain amount of degradation happening. So these are the areas where if you go to sort of coastal communities, you can collect an awful lot of plastic. So rather than now just thinking about what's in the ocean, we're now thinking about what will end up in the ocean later. So these are the areas that are actually there. We've got a bunch of different companies that are collecting stuff from these coastal communities in order to reuse as packaging. Okay, thought I'd cover a few success stories. Who's done well? We've seen quite a bit of alternatives to plastic. I've got a good friend in the UK who is basically running the sort of plastic-free website, trying to find alternatives to plastics for packaging. We've seen a bunch of bio-based resources. Is actually a store which is using entirely plastic-free, still using bioplastic as an alternative. Some companies using compostable packaging for things such as to foods. So there's stuff out there. We're certainly seeing it out there in the world. There have been ways in which we're reducing the amount of packaging. This one's a successful one in the US for the detergent sprays, basically using concentrates as a way of an alternative. And then, of course, we've got the alternatives to current polyester. This one's 100% recycled content. And then you've also got, so the REFUCOAT is the 100% recycled content, so 100% post-consumer recycled content. The Pepsi bottle is the plant bottle. We know that it's possible to go from 30% bio-based to, I think, 8, and then Pepsi now are trying between 75 to 90% bio-based within their polyester. And then the Dasani one is a new one where they're using a hybrid. So they're understanding that it's very tough to get to 100% bio-based polyester. Just because of the two different materials you're using there. So they've got a hybrid. So some of it's bio-based, some of it's post-consumer recycled. All of these, of course, are recyclable. So they're all a polyester and go back into the recycling stream. They're just different attempts to reduce the amount of virgin material in the packaging itself. Oh, quick question. I'm not seeing any questions or comments on the left-hand side of my screen. Should I be seeing that? Are people actually putting in questions? I don't have that on my screen at the moment.
We have one question so far from Anna Maria Mullen. If you open the chat, do you manage to see it?
Okay, let me see if I can do that, because into my screen sharing, I don't seem to have that as an option. Hang on.
Yeah, you'll need to go back to your menu and open the chat. It pops up.
Okay, will I lose my screen?
No.
Okay.
So it's from Anne Maria Mullen. The question is, what insights do you have on business willingness to pay for sustainable material? Maybe a ballpark figure for different types of material. Maybe this relates to technical properties of sustainable materials also.
Sure. We get that question asked all the time. Actually, I was actually sourcing some recycled materials and also some bio-based materials, and yes, and the number's coming down. We know that the cost for bio-based plastics has reduced steadily. The way I always turn it around is, okay, so we've got a phone here, right? This phone cost $1,000. Okay, I'm willing to spend $1,000 on a phone because I see the value. Okay, if you're able through design and functionality to create something that has greater value, then people will pay for it. So what you need to, so rather than just, so what we always tell our clients is, if you just simply just take an existing product, let's say it's a piece of packaging, and simply just replace like for like, you're always going to lose. If it's just a simple material replacement at the moment using a bioplastic, you're going to lose. but what is the functionality of the bioplastic? What does it enable you to do that the other plastic didn't? It's, you know, if you're just replacing it, then you're basically, because at the moment the current water bottle, it's functionalized for polyester. Okay, every bit of that bottle itself has been designed to work best with the polyester plastic. So if I'm going to change that plastic and then still use the same design, I'm already on the back foot. I'm already going to lose. So what we always tell people, if you're going to use a different plastic, work towards its abilities. Does it have a different type of strength, different type of barrier property? Is there something unique about that material that enables you to then potentially offer something of greater value, of difference to the consumer? So just simple swapping of material like for like, an example, what they're doing on this screen, you know, which is basically just having, you are inevitably going to increase your costs, yes. But is there something the bio-based plastic has that the regular polyester doesn't that would allow you to change that? Can they change it from a polyester to something else in order to change that value? So that's what we tell you. So yes, if you're just doing material swap, you'll probably end up paying more. But if you talk to them about how they can redesign and also change the value proposition as well. You know, there are plenty of companies out there who have made their entire business idea upon using sustainable materials. Allbirds here in the US, which is a sneaker company, sells basic sneakers. But because they've talked about their the commitment to sustainability, they have created a huge market share for people who care about that sort of thing. So there are two different ways. Think about the material in terms of way it could change the design, and then also think about how you can change the way that you market that product in order to, you know, to basically look at the conscience of the consumer, the safety, the concern about the, you know, obviously plastics in the ocean, etc., stuff like that. So there are different ways. So just changing for like won't work, but there are different ways in which you can approach it, which will allow you potentially to get a greater chance at getting market share than if you're just than the basic material. Hopefully that answers the question. Okay, keep going on. So other success stories, obviously using paper, whether it's a simple version of paper, just using as a replacement for plastic, or alternatively, we've started to see the use of paper-based materials in more high-performance applications. Carlsberg just came out with a prototype for a beer bottle made out of paper. This Halo Nespresso capsules, again, is using paper-based materials, but in much more high-performance application. One other thing that's worth mentioning as well, this is an attempt in the US certainly, is to go back to the traditional milkman idea, where you're basically, instead of using packaging that can actually break down or is for single use, we're using thicker, heavier, more durable containers. And the idea is that you basically get all your products shipped to you in a box, and then you use them, and then you put them back in the box, and they go back to the original suppliers to be washed and then reused. We don't know whether this is going to be successful, especially now considering COVID. Perhaps we're more concerned about cleanliness and contamination, but it's certainly an interesting idea that we're moving back in time from single-use plastics to things that perhaps are a little more durable and reusable. Okay, I thought I'd include some materials in this. Okay, so I'll just go through a range of different things and the reasons why I'm finding interesting. We started to see 100% post-consumer recycled films. This is a polyester film. What they've done is they've basically taken 100% post-consumer polyester in the middle, and they put two very, very thin layers of virgin polyester on the outside, which allows them to make sure they've got good surface texture and also printability. But there they've got a 90% post-consumer recycled content within a flexible packaging film. We've seen elastomers, rubbery materials, sometimes used as coatings from more bio-based sources. We have those that can be bio-based and compostable, bio-based and not compostable, potentially even recyclable as well. So increasing the number of elastomers or rubbers we're seeing that have a bio-based source. TIPA, an Israeli company, has had some success with metallized compostable films. Of course, the idea being that you can metallize the film because when the plastic itself composts, the metal aluminum film is so thin that it just disintegrates and just disappears. So even though it has metal on it, it's still classed as compostable. So had some success there. Stella McCartney's had some packaging using them. A bunch of different PLA composite materials. obviously not for food packaging, for things like cosmetics. So using PLA as a base source and then adding in some different fibers. This is actually, I think, a German company that's using grass that it's sourcing for composites, uses it in cosmetic packaging as well as even automotive applications and suitcases. Florian, a UK company, claims, so we've seen a bunch of PLA improvements because we know the challenges with PLA, the limitations it has in terms of heat resistance, etc. So there's an awful lot of different companies, predominantly European, who are coming out with additives to change the functionality, the performance of PLA, giving it a little bit more toughness, putting it there in the toughness area between, say, polyester and polycarbonate, to make it there more like a viable plastic that, because we know we've seen it used in certain applications, but its limitations as a pure material have been challenging. So here there are companies adding in performance additives in order to change that functionality. Some performance PLAs. There are different, you've probably got some chemists amongst us, and we know that PLA, there are different types of PLAs. There's a sort of chirality between different forms of PLAs, and one version is actually very high performance that can actually withstand incredibly high heat. So we've started to see those in uses, prototype uses for Nespresso capsules, again, dealing with high heat and pressure, but still a PLA, just a different version of it. And then additives to polyesters, which render the plastic almost like a wax, so breaks down really easily. A company called Timeplast that is adding this to regular PET, so can be recycled in the same way, but also degrades much, much more quickly because the actual chemistry of the material is more like a wax than a polymer. Alternatives to paper that have a little bit more durability. I think it's a Swedish company, might be Finnish, called Paptic. Still recyclable in your regular recycling bin, but has a lot more durability, a little more like a plastic. So Mexicans producing plastics out of avocado pits. They got an awful lot of those. So they found a simple way of making some food-safe straws and cutlery and other things made out of the pits of avocados. And olive pits, again, a sort of more of a composite plastic here used in some more durable packaging. Unfortunately has that color redolent of olive, so has limitations with color, but still has the same bio-based source. We've also seen a lot of lignin. Now, for those of you who don't know, lignin is the other component of cellulose from a tree. So when you cut down a tree and you make it into paper, you got to separate the pulpy, gluey stuff, which is lignin, from the cellulose, the nice fibrous stuff to make your paper. So the lignin typically gets left as a waste resource, but we've started to see it being used now in an awful lot of in rubbers, in leather-like materials, as well as in packaging materials. So it's a little pulpy, but a little gluey, but it works very well as sort of as a binder. And we've seen it in injection molded materials as well as films. Algae in all sorts of forms. Now, the reason why I do love algae, is because it has the advantage of being a material we can source without necessarily affecting arable land. A lot of my clients are concerned about using some bioplastics because of is it going to then take away from food resources? Whether it's directly, say as corn, is it indirectly, perhaps taking the land that typically would originally have been used to produce food. So this, at least algae, is not really taking away from any viable resource. Obviously, it can be used in certain food additives, but predominantly it's just it's a blight. So the idea of using this as a resource is very interesting to me because we're not taking away from any other resource that we would have otherwise needed. Inks, foams, injection moldable plastics, 3 examples of where we're seeing algae being used as a resource. Obviously, plenty of starch-based sources. These have been widely used for a long time. Quite easily biodegradable. Again, with the water-based solutions, the water-soluble solutions, which I'll come to, we've seen a lot of interest in that, and it seems like no one can really get it done correctly. I can remember working with Puma probably 15 years ago, trying to solve using water-based solutions, and just the challenges of wanting the bag to do more, everything it should do. So again, this is always the challenge. If you're trying to develop a new material and want it to replace an existing old one, to expect it to do every single thing that the old one does, you're going to fail. So you need to rethink the use of that material. You need to limit it in some way. So the problem we had with Puma was because they wanted to use water soluble, and it was okay bringing the shoes back from the store back home, but then people wanted to reuse the bag, and then when they wanted to reuse it, it then started falling apart. So the challenge has always been in changing the way that people look at material innovation. Can you rethink it, redesign it so it has a very specific application and works in that application, and then find another solution for the other things that the original material could do? It's a real challenge. So when thinking about any application, understand that the material that had been produced for that application has typically morphed or been engineered over time. It's like when we try to change the shoebox, trying to change an alternative to the cardboard shoebox. It's a very difficult thing to do because the cardboard shoebox has been optimized probably over the last 50 years. So, trying to solve that with just one new iteration is always challenging. So my recommendation to our clients is to just take it off in small chunks. So take off specific needs that you have in one particular application and solve that. Make sure it works for that before you start thinking that one material is going to solve a whole range of different needs. Seen some chitin from lobster shells being trying to develop as packaging, and maybe some of the audience is already working on this sort of thing. Some, again, more starch-based, this time is water-soluble. And the water-soluble ones, we've seen an increase in. We've got a lot of interest from some of the cosmetics companies. Obviously not specifically food packaging, but yes, a lot of interest in how do we develop and move these water-soluble sources further. So we've got ones from, I think this is in Indonesia. This one's actually from spoiled milk in France. So a lot of interest in that, just because the understanding of the and I'm sure you have this problem as well, the problem of compostability. We're having it here in the US as well, the fight between, do I want my material compostable? Do I want it recyclable? And, again, we tell our clients, it depends. And, it's very much a learning curve. A lot of our clients don't necessarily have an awful lot of knowledge about sustainability. They just want to do the right thing. But in doing the right thing, they've got competing concerns. And often the challenge they'll find is that they want it to be one or the other, either recyclable or compostable, but then don't actually know the best one to choose, and will have typically landed on one or the other based upon something they've heard or some other example of successful thing out there in the world. So we often sort of take them through more just what's possible, and then also what is the best solution for specifically their need. So if it's going to be a product that's unlikely to end up, if it's that's going to be in very high volume, compostability is probably not going to be a viable option. If it's something that is going to have a lot of complex parts, then recyclability is not going to be an option. So it's sort of often talking them through the different options that they have, and sort of having them understand that at the moment there is no ideal solution. There is no perfect solution at the moment. So what we're doing is just trying to sort of, again, chip away at certain concerns that they have, and to see if we can solve one or two problems without necessarily trying to solve everything at the same time. Last one I just thought was lolly straw, which was just, again, an edible version. These tend to be interesting and capture an awful lot of interest, and are certainly things that our clients are excited about. But as I'm sure everyone who in the audience knows, is that the ones that capture the most interest and the most excitement tend not to be the ones that will last and will actually be a viable use. So it's interesting, it's good, I can eat a plastic, but am I actually going to do that? No. So often and we spend a lot of our time trying to educate or direct our clients away from some of the stuff they hear in the news. I find as someone who recommends material as a business, news and the articles coming out of places like MIT and well sort of funded research universities can be the worst things out there, because what happens is you'll have some splashy headline which tells us how suddenly this one material can revolutionize the world, or revolutionize packaging. And it's one small amount of information that really just sort of was just one data point in a very much larger study. And the challenge is that the public, including my clients, get hooked on this one thing. And then it becomes a challenge to walk them back into what is actually possible as opposed to what the headline says. So it's just one of those challenges we have when recommending materials. Okay, so where do I think it's going? I think we are at a fascinating inflection point. We were pushing towards sustainability, and it was wonderful, and there's making some real changes and real possibilities. And then this COVID thing hit, and I think what I'm hoping that will do is that will make us perhaps a little more considerate. Obviously, at the moment, when I walk outside my home in Brooklyn and I see all the PPE equipment strewn over the floors, it's not a great sign. The fact that people are just throwing caution to the wind with that type of material. But I do think there is the potential for us now to reconsider the way we live and what we do and the actions that we have. And I do believe that a lot of clients are now coming within the last couple of weeks, coming to us, just rethinking, okay, well, how can we now just engage consumers in a much more real way and a much more sort of thoughtful way? So I think this might be a great chance. I know people are concerned that sustainability in a way has sort of been pushed to the wayside. We're worried about just like people surviving and just general public health. I think at least now there is a possibility to engage the consumer in a more thoughtful discussion about their use of everything. Since we've come back home, we're now more sort of like a lot more, our lives are a lot smaller. I think we're now more considerate of the things we do use. So I think there is a lot of potential now for companies to be a little bit more bold in the choice of packaging materials and just saying, look, we're going to do this because we believe in it. And this is the reason why, because we need to, so I think there is a great opportunity because we don't know what's going to happen over the next few weeks and few months. But I do believe that I think people have had the shock of their lives and now are perhaps a little more cognizant of obviously health and cleanliness, but also the sort of the way that they live and sort of the choices they make. So I think my hope is, and I'm an entirely optimistic person, is that there will be that opportunity to sort of rethink packaging, rethink materials, and perhaps use it in a more conscientious way. Thanks.
Thank you so much, Andrew. That was really interesting. And although you can't see it, the questions have been stacking up in the chat.
Good,
so
good.
I'm going to invite a few people to pose their questions now. I'll start a bit on a first come, first serve. So Luca J has been waiting the longest, so he's got 2 questions for you.
Sure.
Yes, hi, good afternoon. Andrew, at first, thank you very much for your presentation. It was very informative. My question would be what do you think, how the bio-based plastic can be recycled, and is it requires a special infrastructure?
Well, obviously you've got the bio-based plastics which mimic regular plastics, the Coke bottles, etc. So so I think if it's possible to do that and to fit in with existing infrastructure, we should certainly do it. I think because it's clear that very little is biodegrading in the ocean, so recycling and compostability is not really working. Certainly, I mean, I don't know about Europe, but certainly in the US, no one's really doing it effectively. I think it needs to fit in with existing ones. We have a problem in the US that even though we did have a bioplastics designation, the organization that does the various different numbers here in the US from 1 through to 7 in terms of recyclability, they were going to do a bioplastics one, then basically decided against it. I think Europe is different and unique in that you already have considered this and do have different, different places where you can put different types of plastics. The US and the rest of the world, we're kind of lagging behind quite a bit. So even, the challenge will be stuff that you can develop for Europe and that will work well for you won't necessarily work as well for us. That's the problem we've always found, is that the different global regions, ideally, yes, it would be nice if you can recycle it. I think there is going to be a lot of chance. So I think the ideal will be if you can fit it within existing ones. If you can make it mimic existing plastics, that would be the ideal. I'm not sure. The alternative infrastructure at the moment, I mean, there are probably a lot of alternative bioplastics. How do you then, is there enough critical mass of those materials to then make recycling viable? Polyester's good, as I mentioned earlier, because it has a critical mass. Other ones, if I've only got it in very small sections of certain amounts of product, creating an infrastructure for that might be really challenging. Sorry, that's not an ideal answer. It's just, I think it's going to be a challenge. You had a second question?
Luca?
Oh, yes, sorry. Yeah, thank you very much for the first answer. And my second question is a bit different. I'm wondering about the bamboo as a sustainable material for using as a packaging or just to substitute some regular plastic products with bamboo. What do you think?
Do you mean using plastic as in its inherent, like it's as itself, or synthesizing it into a new chemistry?
Yeah, I'm thinking to synthesize it to a new material.
I mean, if you can, certainly it has large volumes of production. It is already an industrial material. That's the thing. You know, like the advantage of cotton and wood and castor beans is that they're already industrial materials. So we don't necessarily need to take away from food sources. Bamboo is already the same. It's used as an industrial construction material. Grows quickly, certainly. There's lots of it around. I do remember, you know, and it is claimed to be, because of its fast growth, because it's a grass, I believe, it is supposed to be a good option. I haven't seen that many bioplastics made out of bamboo, and I'm sure, obviously, the audience here, there's probably people working on it. If we can start getting some viable plastics out of it, sure, I think that's a good alternative to some of the materials out there. I don't know yet of anything that's being produced specifically from bamboo, though. Maybe does anyone else? Anyone have a sort of another? I would love to hear that if there is some. I would love to find out about it.
Sounds like they're not with us today, unfortunately.
Okay.
Okay, I'm going to move to the next question. So this one's, well, I'm going to invite Jose Angel from INEA to unmute and pose the question.
Yes, yes, I'm here. My question is about PET bio-based, because PET bio-based is a good option as a raw material for manufacturing bottles. But later, as when it is waste, we have a waste as a PET. Obviously, we can use it as in a recycling process, but we have also to implement the recycling process. What's your opinion about PET bio-based?
It is one of the good options. I mean, obviously, we know we can produce 100% post-consumer recycled. We know we can produce small amounts of bio-based in PET. We know we can produce larger amounts of bio-based. We can go up to 100%. The challenge, of course, is cost and ability. I think the advantage of polyester, as I mentioned, is that you can make it into more bottles. You can make it into other things. And there already is an infrastructure using recycled PET. So, and of course, there's obviously mechanical recycling and chemical recycling. Ideally, chemical recycling would be the way to go, because then we don't lose performance and we can do it potentially infinitely. But I think the process is hard it's not an easy thing. There've been some pilot plants. They haven't had a huge amount of success in terms of return on investment. But, so ideally don't use the water bottle, use something else, you just use a reusable bottle. If you're going to use PET, yes, bio-based is better. Let's use some of the existing PET. Ideally, you would use, of all the bottles out there in the world, as long as that's enough, you simply just recycle them again and again and again, if you could do that, if you collect all of them. But given that you can't, so therefore you have to use some virgin, bio-based is a good option. I think the ability to also have it fit directly into the regular recycling stream is probably ideal. As I mentioned, if I can make all bioplastics fit into existing recycling streams without needing to increase the infrastructure, that of course is going to be a better solution, because we already have resources, we already have a market for recycled PET, for recycled polyethylene, high density, low density, for recycled polystyrene. We've already got a market for those. Let's use that market, because if you're going to recycle something, there's no value unless you can actually reuse it again. So I believe in it. I think and maintaining the so PET is actually a good option. I think bio-based is good as well. Where did it come from? Where does the actual bio-based stuff come from? What resource? Does anyone know?
As far as I know, they comes from plants. I know it that Coca-Cola and other bottled water companies are using this kind of bio-based PET.
So is it sugar-based? So therefore, is it a food source or is it something else?
I don't know which is exactly the raw material.
Okay, someone's got to know on this call. Come on.
In fact, it's me, Ulf. The plant bottle from Coca-Cola uses bio-monoethylene glycol as one component. And the D acid is still petrochemically based.
So the bio-based is so that chemical, the bio-based chemical. What's the source of that? Is it a wood-based source? Is it a sugar-based source? Is it cellulose? What's the resource for it?
In fact, it's sugar-based.
Okay. So yeah, that's not ideal, but I guess we've got enough. I mean, I guess there's industrial sugarcane, that sort of thing. So not all of it's food-based. So I guess that's probably, yeah. I guess that's not ideal, but certainly it's okay.
Okay, I think we have time for one more. So I'm going to invite Simon Kemmerling. Can you also please introduce yourself, what organization you come from as well when you ask your question, please?
Yes, of course, I can. My name is Simon Kemmerling. I'm from Fraunhofer ICT in Germany. And my question is related to the PLA, because you already mentioned the poor performance and at elevated temperatures. And in the recent years, there was some research regarding stereocomplex PLA to overcome this issue. Did you hear of it? How do you see the potential of, let's say, not using any additives, but just pure PLA and making a stereocomplex material out of it to see some higher value applications for the PLA itself?
Mm-hmm. Yes, Corbion is a company that's doing that currently. They are one of the only producers of that. As I mentioned, the chiral mirror mirrors sort of different chemistry. They did some prototype Nespresso containers. They've done other different bits and pieces. At the moment, their main application, I'm sorry to say, is in strengthening fibers for fracking. So they use PLA as part of the water that goes down into fracking wells as a way of basically forcing the resources back up. So that's their main application of that higher temperature resistant PLA. Yeah, they want to use it. I think the cost is a challenge at the moment. It's still a little bit more expensive. It tends to be more for more high performance applications. I worry also just because you've got only one or two companies, Corbion and maybe one other. You don't have an awful lot of other people experimenting. I wish they sort of open it up a little bit more and have more people play with it. So yes, would produce much more high performance PLAs, certainly to withstand, I think 230, 250 degrees C. But I haven't seen anything out there yet other than sort of industrial applications. Would love to see more. Clearly it is higher performance. I think at the moment though, just cost and availability means that everyone's using the basic PLA and then just trying to enhance that performance. So would like to see it, haven't seen much yet.
Thank you very much for your answer.
Okay, that's all we have time for. We left a little bit extra because we had lots of nice questions. And I'm sorry that we didn't get to everybody's questions today. But thank you so much also for joining us, Andrew. It was really interesting to hear your presentation and also your answers.
Thank you. Nice to meet with all.